So let's continue looking at structures. Again, so creating your own data structures with struct. And again, I haven't really just briefly touched on the fact that you could potentially use member functions inside. You could define your own constructors, things you probably know already from OOP, before, like in Python, and you can do that. But what I want to do also, let's first finish the slides and also see how you could include it. Typically, structures are defined somewhere else, like in another header, somewhere outside of the main function, basically, because of course you will be have your own library of your own things, your favorite structures, right? You don't have to keep reinventing the wheel, right? So let's finish our so comparison, right? So for comparison, we are looking at the fact that you don't have it. Yeah, you don't have it, so you have to make a, so you have to make a function, basically. Let's do that. All right, let's compare it. So for now to compare two players, we would compare all their values, right? So in this case, it's really easy, right? So fun, Boolean, it's not very efficient, but what else can you do, right? So basically, we could add a function to this, right? So Boolean, right? Are players equal, right? Player P1, player 2, on, right? So again, it thinks, okay, AI, but let's do this basically, right? So what we do, return false, right? So this approach, of course, works. Or in fact, is this needed? By the way, this part here, right? And this part here, right? I think what we could do is, of course, if you want to be really code golf a little bit, right? We can just return this, right? Classical programming. That's all we did. We can return all of this, right? Right. So we can optimize this, right? We could do it in a single line. We do not need the if here, since we are returning a bool or a boolean, right? So return, this is completely fine. Question is now, of course, I could do this, right? I'll do like this, right? Just tab formatting. I don't know, actually, I wonder how can you format the code. Again, remember in C++, you don't need to worry about formatting, but well, there are built-in formatters, right? So, yeah. So this would work. You can also, of course, doesn't matter where you put the and, right? So this is now, we have a function to compare. We can compare two players, right? Player 4 and player 3, right? So let's compare, right? So if, right? And obviously they're not different. They are different, right? Let's copy. Let's create fifth player by copy player 4. So player 5 equals player 4, and let's compare it. And we should see that they are same. And again, when I say same, I don't mean the actual memory. It means actually the contents. So you can think of it as same, two different shopping carts, right? Have same. I'll say this: have same contents, right? Not necessarily a memory location, right? Yeah. So that's what I should mention, right? Content. All right. Compile. Oh, it still compiles. That's good. Yeah. So player 1 and player 2 are different, and player 4 have same contents, but not necessarily the same memory location. Okay. So yeah. Again, so we use this approach that players are here. So now let's move this, right? Let's move these two things, right, to a separate file. Right. Let me commit this. Right. Comparing struct. and synchronized, I guess. Now, so let's move this to a header, and that's not completely straightforward. There are some gotchas here, actually, how to move it, right? Because of course, we're going to use it, because we're going to call it game or my game structs or something like that. We'll do like something like game structs. I'm still used to using what you call snake case from Python type, but we should be using camel case here. Switch back and forth is kind of painful, but let's do this. Okay, so I'll call it so game or game structs, right? H, right? So H, header, right? Actually, it was a triple header. I think H is fine, right? Game structures, right? And now I will place point on player structs, right? So Control V. No, let me copy this, right? Let me copy since I'm lazy. Control C, Control V, right? So on string name, well, what do I do now? Well, I need to include it, right? And now we get to this part here, string, right? I need string, right? Yeah. We need to include it since I'm using string in, right? And now, of course, the thing is, how do you avoid the fact that including same thing multiple times, right? Well, maybe a possibility, a problem, right? Now, so how do we use it here? So I'm gonna just get rid of it, right? That's it, gone forever, right? Now my structs are in game structs H. So that's what I'm gonna do. Include, right? So I should probably use them here, right? Right. My structures are in game struct H. So notice the dot H, right? So basically, I take it from there, but notice I'm including string here. Well, I'm assuming, right, that game structures, that string has protection, right? So this will work for now, but it's not completely great. Let's take a look if it compiles. Okay, it does not compile. Let's see. And because I didn't include it, well, let's look at all the nice C++ errors. Now, string does not have a type. You mean std in? Okay, yeah, of course, right? So this is std, right? You see, look at this. I mean, single typo, right? I could have used using namespace as well, right? Let's try this one more time. Because we didn't have namespace yet. Okay, compiles, and now nothing should be really changed, right? Nothing should be changed. It all works, right? But again, so why do you do it? Why do we do have separate headers? Of course, because it's considered good practice. Again, experience shows that you set your data structures separately, basically, right? What you want to be done, so you design your data structures first, like what you're going to be doing. Obviously, it could be possible during your development, things will change, right? Maybe you need something else, right? But again, this is good practice. But that's not all what we have done. We need to add something called a protection, basically, right? Kind of like a main protection in Python. So the issue is you don't want to include multiple times, right? So what we do is, right? Now we want to include, right? Now I will placing declaration. Right. Now it is good practice. It is good practice. Yeah, pragma once. It is good practice to protect. Yeah. Also, we want to use pragma. Yeah, we want to use preprocessor directives to avoid multiple inclusion. Again. If you're doing your own files, possibly it's not going to be the end of the world, especially if you're doing structures, but it's still a good protection. So what do? You do this. If, include guards. Right, so how do they look like? Yeah, so let's show this. If, I don't think this is in GCC, pragma once, right? This used to be, it used to be non-standard, I think, right? That's one approach, right? Older way, sure way is to, yeah, so I'll show you this one as well, right? This is one way, use it if your compiler supports it, right? Now, the sure way is this is the old school way, right? So you do if not, right, define. So basically, it is we're saying if this is not defined, we define it, right? And then, right, what do we do at the end? We need one more thing, I think. We need to stop it, end if, yeah. End if, right? So we need to also stop it. End if, right? Or, yeah, end if. I think, yeah, end if, yeah. I keep forgetting things. So end if, right, stop the macro, stop the definition. Yeah, of the. Okay. So again, so what this means is, right? So how is this going to work? So this means if at some moment you have a big project, you have multiple files, and you are trying to include this game structures age, right? So if you have not defined it, right, nothing, you're going to make this constant, basically not constant, this macro, basically, right? And then you have all the other stuff, right? You include the string, right? It has its own protection, right? Presumably structure point, right? You make your own structures, you have functions and so on, right? You end if. However, if you're already using it somewhere, this will be already defined, right? Again, this name, you could come up with your own name, it's up to you, but of course, the name is not specific, right? And then you only have, this means you are guaranteed you only have all this nice point, you have the player, right, and you can use it. So okay, that's a so-called include guard, right? So that's something you can look up. Again, if you encounter C++ projects, you will see this used quite a bit. Again, it's kind of similar to main guard in Python, right? When we protection, we check something and we do something, right? A little bit similar, not the same, of course, but idea. And it's common in other ways. Of course, if your compiler supports pragma once, that's easier, right? You say, okay, use it only once, because you don't want to include multiple times. No. All right, so let's compile one more time. Oh, now we run structures and everything works. Okay, I think this is almost finished, but let's see, yeah. So no aggregate operations, yeah. Yeah, one member at a time, yeah. So no, we don't have aggregate operations. Yes, you can get passed by parameter or by reference, right? But if you have reference, you could change things. So, array, arithmetic, no. Assignment, yes. Input, output, well, strings, no. Comparison, no. Reference, or value by reference. And function returning value, yes. We can return a structure, right? We can function can return a structure, right? That's arrays. You return a pointer basically. But so for structures, you can return structure. Let's take a look if we can do something. Let's make a function that we were comparing, right? We were comparing here, right? Let's make a function that returns a. Let's make a function that returns the player with highest score, right? Yeah, get best player, right? So we are getting player back, right? Let's make a player structure, right? So we get player back. Player 1, player 2, right? So you check the score and you return particular player, right? Simple function, right? I think there's Patrick and who else had scored? SpongeBob, right? So we'll compare Patrick and SpongeBob. I think there's player 2 and player 3, right? Player 2 and player 4, right? Now, let's get the player with highest score, right? So we'll do player best player, get best player, player 1, player 2, right? And of course, again, function, you have to check whether what happens, right? And of course, this is of course a copy, right? So best player, right? And let's double check. Yeah, SpongeBob beats me, right? SpongeBob beats me, and he has 100 points, right? So again, yeah. So what else? What else? What else? Arrays and structures. Yeah. So So if you want to have a fixed size array in structures, yes, we can, right? It is, of course, again, we have this problem, right? That how do we get the size, right? Of course, we have the constant, right? We'll probably want to have the length, right? Maximum length, array size, right? Saved as actually, right? Inside, because of course of the possibility that we go out of bounds, right? Because there's no real error checking, right? So we'll see if maybe we have time. We'll do a little maybe Sudoku or something. We'll try to define a Sudoku board maybe or something like that, right? So arrays and structures, right? Yeah, we can do things like this, right? We can have, if we have structure, of course, we access it inside array. In this case, we have an array, right? We can, of course, adjust it, right? We have second item is 37, of course, we do plus plus. List length, of course, here it is, we are adjusting sort of like doing two things at once, right? We're doing adding some items, some data, right? Because originally we don't know how many items we have on list length, 2 items, right? Because, well, we are manually keeping track of how many items we entered in this array, right? So it's sort of like a thin wrapper over an array, sort of like, okay, you have 1,000 items potentially, right? Capacity, right? But again, vector does it already for you, again, so you don't really need to use for your array things, right? Because this is much more likely to happen, right? You have a employee type, person, first name, last name, ID, string, money, yearly, monthly, year-to-date paid, monthly bonus, and so on, right? So of course, this type of stuff is very common, and you get from database or somewhere, right? You need to read it. Not as much fun to redo it in C++. Many other language it's easier, but yeah. What else? Yes, the fact is, of course, you have multiple levels of this nesting. You have address, of course, you have structure. A new employee has the name structure inside, address structure, like what we did here, like my simple example, or player, right? Or players, well, here, right? It much makes easier to look at the structures, right? Player has also point inside, right? Point, which is our own structure here, right? That's completely normal. Now, that is, yeah, fixed number of components, right? Required word, right? Memory is allocated only when variables are declared. Well, makes sense, right? So, dot member access operator. Yeah, again, so we are skipping, today we are skipping the member functions, right? Because those are classically related to classes. Actually, we can use them in structures. Basically, again, the dirty secret is that structures are actually classes, but with open public access, basically by default. You can switch them around, actually, right? So your use case for structure should be when you have data, plain data. Basically, you just want to combine some data types, name, age, and so on and so on. You want to combine it. That's when you use structures. We will be using classes in next lectures for doing something more complex things. Again, you can use structures as well, but sort of like thematically, classes will be more appropriate, right? You do more, right? Again, so we also learn how we can do a header, right? Okay, now we have like 25 minutes. Yeah, we have 25 minutes. No, yeah, 25 minutes. Let's see if we can do Sudoku in this. See how easy it's going to be. Probably not as easy because C++ is much wordier, but let's take a look if we can do a solver for Sudoku. Also, we have to do, of course, to do a nice solver, you have to read the file and things like that. But let's do maybe a fixed size solver for now, which is not very good, but we'll try it. Sudoku CPP. Let's do let's create a Sudoku solver. We will use an grid. So for that, we will create the board structure, right? With array inside, array of arrays. All right, so let's do that. Yeah, of course. Yes, of course. That's also given. What else do we need? Yeah, of course, right? Easy. And of course, we'll need a function to solve the board, right? We will use backtracking for that, right? We also want to keep track of our moves. So move struct also would be helpful. So moves, I'll do capital, right? I'll helper moves on the board structure. Okay, so we have board and moves, right? Okay, let's do that. Let's get started. Yeah, print the moves. Yeah. Okay. Now, undo the last. All right, no problem. That of course will need a stack movement, the structure thing. Right, so lots of things to do, but they're not too horrible tasks, because we already did this previous lecture in our algorithm, so this should be, well, relatively doable in 20 minutes. Can we do it? Yeah, of course, make a move. Maybe, I don't know if we need to make a move. Yeah, we need to make. Okay, now, so let's start. Let's start. So board, yeah. So two-dimensional structure. Question is now, of course, do we want to have anything? Do we want to store the? Do we want to adjust we could also add a move counter, right? Or we could add moves here, maybe moves first. So the thing is, do we want to keep the moves? For now, right? Right. So this is simple, right? Yeah. So how do we print it, right? Yeah. And of course, this is 9 by 9. If you see all these 9s, right? See out. Of course, we need, using namespace, right? Yeah, using namespace. Include IO stream, right? On using namespace std, right? Again, board, print board. That's just going to print the board. Okay, that looks pretty good, right? Now what else do we need? Right. So we're going to give it the board, if a number. This is going to be much more difficult. Right. Is valid, Boolean, right? Row, column, integer number. So we check what is in the row, check is in the column, and check this, remember this logic, right? Row minus row divided by 3, row by 3, looks okay. Again, it's possible there's hallucination, we'll have to check, right? Again, if you're using AI assistants, again, which is, again, that's the very standard these days, last few years, you should check again and follow the logic. If you don't know what the AI is doing, you should probably do it yourself first, right? So, it looks plausible, right? And that's the danger, right? That's the danger with assistants, LLMs, that they can generate plausible looking code, but make a subtle error. It looks okay to me. It looks to me okay. Probably could make these refactor. This, of course, these should be also separate functions. Again, the numbers, right? So, return false, return false, return false. Otherwise, default, right, is true. Okay. That looks good to me so far. And yeah, Boolean is false, right? Function definition. Now what's next? Yes, solved, of course, it could be if it's, that means it's solved, right? Right, go through all of them and see if it's solved. Okay. And now the magic. So how do we solve it? Intro, find an empty, right? If found, so let's see how we do it. For row, if find an empty position, okay. Let's see, I'm a little bit curious about this. So, I know what, yeah, okay, yeah, okay. Important point, important. Notice, note, we are, let's say, looped to keep them in scope, right? Important point, right? You know, something you do not worry in Python. So because I declare them here, not here. Ordinarily, in ordinal loops, I would say intro here, but I need them in this approach, right? When I find place, right, which there's empty spot, then I can try to fill it, right? And of course, what I do is this: is it valid? And if it's solved, right? Now this all looks good. But the question is, I have a problem. Is this going to solve it? Well, no, it's not going to solve it. Because why? There's no backtracking, right? This is just going to try to attempt to fill it, right? But is it solved board? Oh yeah, it be right. If it's solved, right? Right. Otherwise, yeah, no, it's a recursive solution, so it might actually solve it. Because the backtracking is built in recursively. Okay, let's take move structure, right? And the moves, we need to preserve the moves, right? This actually would be kind of, we need to put them up here, right? Yeah, I'll do them here. Moves, I would do a vector because I'm lazy. I don't want to do any. Right, moves, right? So to keep track of it, right? So maybe we'll do it. Let's solve it first. Right? Let's try to solve. Let's try a sample puzzle. Let's do a sample puzzle. Now, since I'm lazy, as usual, right? I would like to read this function, right? Let's read the function from file, right? Why not? Let's see. Let's make a function. Let's make a function to read puzzle from text file in 9x9 format. Yeah, empty, you know, and 129 for field. Yeah. So space or new? Yeah. We will use a new line to separate rows. Okay. No space no on columns will be next to each other. Okay. No, we don't. Okay, we can write also. All right. So read first. Now let's make a read function. This is how they start. So this is bool. Bool meaning board, right? Stream. I need, of course, IO stream, right? std. But let's see. File, right? If stream. Yeah. IO stream, right? What do I have here? Also need file. F-stream, right? F-stream. Okay, this is actually this is like lecture about 10 lectures later, right? But I'm showing you right now since you guys are smart, and also it's not that horrible. Now it should work. String file name, board, right? If file isn't open, you cannot open the file, of course. Now let's see. File to grid, right? We are going through. We have our board, right? We read the board, empty board. On the file to grid, this looks pretty easy. Actually, only question is this actually going to work? It might. If this is a good file, of course. There's no error checking, right? There's no error checking. No error checking, by the way, right? Okay, so I need to, of course, make a file, right? Right. Now, our main will read and print the file. Board. Okay. Int main argvect, of course. Arg count, int arg count. Come on. Yeah. Right. Board B. Note, right? So, if could not read the board, initial board, print. Okay, well, I'm not going to solve the board yet. I want to delay it. I want to delay the satisfaction of solving the board. I don't want to rush things. But at least, so this is how I will start. So this is what you should start, actually, making some kind of application. Well, read, bless you, read state and print whatever you have, right? That's how you should do. This is your hello world, basically, for your application, right? If you get this far, this means you could probably start solving it, actually, right? Otherwise, of course, it sometimes happens on your midterm or any application, right? You will have to do something similar, by the way. On your midterm, you have to read text file. I can tell you already, right? So to figure out if you actually, if you're getting data in, basically, right? Otherwise, you have this solution, everything works great, but you don't actually have data in, right? So what happens, of course, people inevitably end up, hard coding, copying things in, right? Getting the first version working, right? But that's not great. So second argument, we'll try to read the board. This is very simple, right? Okay, let's see if this works. So let me come up with the Sudoku, and I will probably see if I can make the one from Wikipedia from our previous lecture. Let me see Sudoku. Wiki. Yeah, I'm going to be lazy. Yes, I'll use this one, right? I'll use this one. Right, so I just need, of course, I'll do quick and dirty. What we call it? Sudo viens, I'll call something silly like sudo. So sudo viens text, right? It's text file, right? So I'll just need to do this, right? I'm lazy. Again, so 53007, right? 000, right? Looks okay. 600195 and also 00, right? 098 00060. And of course, advantage of this is that you can see if you're making something horribly wrong, right? You can still make a mistake, but most likely, again, you could parse this Wikipedia page. Again, somebody who wants to write a parser for this would be good, of course, right? But 5 rows, 6 rows, 7, 2, 6, right? And 0, 0, you see, 0, 6, right? And 2, 8, 0, and easy to 4, 1, 9. That's 8, 0, 0. No, you see there's a mistake already. 8 and 7, 9. Okay, that looks decent, right? So now, of course, the big text. Can we read this? Is our code, is our Sudoku solver actually? But if you saw any mistakes I make, you let me know. What's happening in the middle? 8603. This looks mistake. You see, I made a mistake here already, right? 803. This whole thing is bad. How did I do this? You see, dyslexic? No, I'm not dyslexic, but I don't know. Well, I mean, yeah. That happens. Call this very, very typical. Yeah, you're rushing.
803 instead of 804.
Yeah. Fat fingers, sorry. So, looks now okay, but again, I'm not 100% sure, but it looks decent. Again, it's so this is something I would recommend to you have. If you have an easy way to quickly have this sanity check, right? Soundness check would be the new language, actually. Soundness check, right? You cannot say sanity check; it's not allowed, right? So people who are not insane, they will be angry, basically. You know about that, right? Serious? Yeah, this is a language code, right? So I don't know. So Sudoku. Let's try it. So first of all, I'm going to compile. That's a small step for mankind, right? So Sudoku CPP, come on, output sudo. Well, sudo not a good name, right? Well, sudo because we are on Ubuntu, right? So I'll do SU also. Yeah, it's well, of course you're not gonna be using SU as a system name. It's kind of a little bit. I'll just call Sudoku, right? Sudoku, all right, and it compiles. Shocking, but I know. But yeah, on. So will it work? Please provide a file name with Sudoku puzzle. Okay, sure, I will do that. I'll do sudo 1. Oh, okay. Something did not, well, what is going on here? Okay, so printing did not go well. So something did not go well. Exit fail, right? Exit failure, right? Exit success. This is basically 1 and 0, by the way, right? But what did it go wrong? Our printing did not go wrong. We have a blank board, read board. We gave a reference. It should have read the board, right? So what happened? Initial board. No, there is initial board here. It worked, right? Looks like it worked up to, right? So what happened here? Why did print board work? So this is hallucination. So what it looks like, right? It kept printing, right? So what happened here? We just want to print. We didn't do anything else. So what's the problem here? This looks decent, but we have a board, right? We have a grid. What's wrong? We have a nice looking grid here. This looks really, really good, except it doesn't work completely well. So we have a IJ1. Oh wait, let's see if there's anything which is like obviously bad. Why didn't it work? It looks decent to me, right? I mean, at first glance, right? So if you divide evenly, you end, right? So why is it just because of the numbers? Maybe. Okay, what are you trying to do? See out. Where's the number actually? This part here, right? And this is an integer, right? Maybe 1, 2, 3, 4, 5. So it looks like, for some reason, I know what the problem is, right? Do you know what the problem is? I can tell you. Who can tell me what the problem is? I know it's a kind of a, where the problem is? Who can tell me? What happened? The printing works fine. Do you see the issue? What happened here, right? Well, okay, I have my data. It looks good, right? The problem is that's why the book, well, not the book, but the AI was saying space separator. What happened is, check this out here, right? When I'm reading, right? Read board. Where's my read board? The problem is in read board. Okay. Right, if stream file, right, this part here, right, I have file open, file stream, right, I'm filling a grid, but what's the issue? I have my numbers, single row, right, they're not separated. How would the parser expect an integer, right, this is an integer, grid is an integer, right, the value, and that's an integer here, right, it's a full integer, so I got 9 values here, and I have 72 values not filled, they had just garbage. So in a way, garbage protected me. I see that it's, so how should I fix this? But the way I see this is, this part here should be char, actually, right? So I'll do a char, right? Right, and I'll convert it to, or unsigned integer, right? A char would be fine, right? We'll use that. We will use char to store digits, right? Char digit, right? And then this will work, right? To show you, this was a mistake, right? Digit, right? And then of course I convert it. So I'm not gonna check. We could check, right? But 0 or 9, right? But no, but but later, right? So now, that is the part. Yeah, this is the beauty, right? So basically, yeah, that would work, but no. No. We don't need. Well, yeah, actually, it would work. Yeah, that also works because we can use this. Because why? Right. Because here, right? These are strings, right? So this is basically a little ugly, right? But a very popular approach, right? In C++, not as fun, you know. Very popular approach, yeah. So digit -1. So this works because you have digit, right? ASCII code, right? So we want that's 48, right? That's 48, and we'll have something, right? We are guaranteed. So this should work now. Now let's test it. Compiles, beauty. Oh, and it works. Yay. So we have our grid. Yes. Nice looking. Okay. So yeah, so this trick, yes, there should be something, there might be something now nicer. This is the old trick, but it's again, AI knows this very well because it's been used pretty much in most of the codes. Again, if you're using modern language, you don't really want to use it, but it still works, right? Because we parse here, we parse each card that is not new line, right? Here we parse each card by card, right? Digit, right? So a little tricky, but works. So we can print. So we have success printing. Let me first. What do I need to? I don't need this binary. I want binaries into a Git. Those blobs. Reading and printing Sudoku. Now the big question is going to solve it. I don't know if it's going to solve in 3 minutes. Yeah, let's do this. And now let's try solving it. Why not? Let's try it. Yeah, board, but it is recursive, right? We'll see. I'm not sure it's going to work. I have a feeling it might not work because is there backtracking built in? Because the same structure is going to fill out the zeros back. Or maybe, yeah, it does. Does it have it? In solving, we have structure here, by the way, outline. Yeah, by the way, notice here, right? You have a board, right? Your print board is valid, right? Solve board. Does it set up zero somewhere here? If phone, yeah, it does. Okay. It looks promising, right? It does, but I don't make any guarantees about my AI slaves, basically. Sorry, guys. So let's try it. It compiles. Okay. It solved it. Yay! Pretty good stuff, right? So it's solved, right? Looks good, right? So, and again, you can see the approach, the backtracking approach used by the solver here, right? It tries to solve it, right? But it's used a recursive call, right? One thing I'd like to do, create a solver that is not recursive, right? For that, you probably need a move, right? You need some way of resetting, basically, right? It's not recursive, right? It's also not hard. We would simply, yeah, and then backtrack if needed. Okay, so that's something to do next time. Maybe not next time, but right for yourself if you want to practice. All right. So what are we going to do next lecture? So this went much better than I expected. So yes, as promised, classes and objects. Yeah, so actually you saw something very similar to class actually today, but we will look, of course, at the class-specific things. We want to look at member functions. We want to do some things inside the class, or instances of our class. Okay, and you'll have some pretty decent homework also on Thursday. So thank you everyone today.